Hi friends, so now next we will continue with this calculating the inverse, um, and this is a little bit again lot of math computations are required. So I have done this work a little before, so I'll just explain through. It did take me quite a bit of time to write down everything, so we'll go through a little bit slowly, but not as slow as it would have taken for me to go through all these manually, and then I even made some mistakes which I corrected, so you don't need to hopefully waste time learning all that. But that's just the process, right? So when you look at somebody presenting these things, you think maybe they have some special tricks. I have been very impressed by some people presenting these kind of materials online, uh, just thinking that I would never be able to do it. But if you actually see somebody work through all these things, they just have to take the time like anybody else, right? So there is no shortcut to these things. So I did record a video and I made mistakes, and then I had to go back, stop the video, correct my mistakes, and then I got everything all right. Okay, so anyway, let's get started calculating the inverse. So you have a matrix A which belongs to Rn by n. Okay, so we start this, and in this case we assume that this matrix A is invertible. Okay, so that's an assumption. Will be nice. We will not give, or we will not deal, at least in this section, with matrices that are not invertible. Okay, given that this is AR by n and A is invertible. Okay, so we'll make that assumption. Then our goal is to find a matrix X such that AX equal to IN. Then X is A inverse, right? This is from the definition. So this matrix you multiply, you get the identity matrix IN. Okay, and this X is in the book they have written it like this, x1 to xn, because they are writing in regular text. This notation is used in to say that this x1 to xn are columns, right? If you remember from our previous videos, we were solving things like ax equal to b, correct? But here what we do is this is very specific b's, right? So what do I mean by that? So if I take this A matrix and I multiply by some this x11, x21, x31 up to xn1, right? So let me write it here. So this A matrix, right? And then I have this first column that I'm taking. So that is x11, x second row first column, and then x nth row first column. Okay. If we did only this, I take the A matrix, we are going to get, before we put some arbitrary b, but now we don't want arbitrary b, we want just the first column of this in, right? So 1 0, this, correct? And similarly, when you take the second column, this x2, it's going to be a x21, x22 all the way up to xn2, and that should be equal to 0 1 0 and everything else 0. That's the second column of in, and so on, right? This is a very neat way to express all of those n equations with one augmented matrix, because this really doesn't matter what these are, right? Because A is what is we are going to deal with to get into that row reduced echelon form, right? So what we are doing is we are basically solving this system of linear equations. Like this we have n equations, right? And we are solving all of them in one shot, right? So if you want to think about it, we want some column vector, so A multiplies that column vector to give 1 0 0 0. That is going to be the first column of A inverse. Then we want some other vector, right, which is the second column, this x2, which this A times x2 is going to give us this column, and so on, right? And this is just a neat trick to put the identity matrix here, and then you do this reduced row echelon form, then this becomes your answer, right, which is A inverse, or the X that you are trying to solve, right? I hope that one is clear. Think about it a little bit, because before we did Ax equal to B and we were solving, except here this B's are the columns of the identity matrix, right? That's what these guys are. Okay. So this is the example that is there in the book, and then this A matrix, this is example 2.9. Okay, 2.9. So that's this example. So they have this A matrix. So we take this A matrix, which is square matrix, and then we put the 4 by 4 square matrix here, and then we start doing our elementary transformations step by step, right? I'm going to go through this little bit. I did make a mistake here, like I said, a small mistake, and it happened to carry through the next couple of steps. So you have to be careful and patient and slow, and make sure everything is correct before you move on to the next step. Okay. So I'll just explain this the steps. So this is the pivot. As you know, 1, conveniently we got 1 here. So here we have to take R2 minus R1, and then R3 becomes R3 minus R1, R4 becomes R4 minus R1, because we just want to eliminate these ones, which is what this is. Now we got the pivot here 1, and we want to eliminate this 2 and 1, make them 0. So R3 is R3 minus 2R2, R4 is R4 minus R2. Okay. So we do that, and once we do that, we get this matrix. In this case, now we want a 1 here, right? The pivot. I did not want to multiply this by half and deal with fractions. So I swapped R3 and R4, and I got this. Okay. Now once we have this matrix, as you can see that one mistake is carrying throughout till here. Okay. Before I realized something was wrong. Okay. Okay. So let's move on. Now R3 and R4 are swapped. I'm going to remove this sheet, put it aside, and go through this step. Now R3 and R4 are swapped, so we got this, and then the next step obviously is to eliminate this 2 and make it 0. Then that will get it into this row echelon form, which is fine, but I am trying to push this towards the reduced row echelon form, so that's why I am also eliminating these guys. That's why I'm doing R1 is R1 minus 2R3, R2 is R2 plus 2R3, so this minus 2 will go away, become 0, and then R4 is R4 minus 2R3. All right, and you carry out those steps, you end up with this matrix. And as you can see, the bottom row is -1. We have to make it +1, so we make it +1, right, by multiplying this row by -1. That's it. And then now we have to eliminate these guys, so that's R1 is R1 plus 2R4. So that's, you add this 2 times and then add it, this becomes 0. Multiply by -2 and add it, then it becomes 0. Then this guy is just -1, and then you just R3 is R3 minus R4. Okay, and then we do that, and if we do all that, then after doing all those steps, you get this guy. So the identity matrix has been pushed to the left, and then we got A inverse here. Now how do we know that this is actually A inverse or not? Then the best way is to actually go through the math yourself. So what you do is we take so let's see if A inverse is A inverse correct, right? We are verifying whether it's correct or not, right? So how do we verify that? So I take the original matrix A that we started with. So that is 1 0 2 0, 1 1 0 0, 1 2 0 1, 1 1 1 1, multiplied by this guy -1 2 -2 2, 1 -1 2 -2, 1 -1 1 -1, -1 0 -1 2. Okay, and you can do matrix multiplication, which means I'll just do, maybe if it's not too hard we can do it. So 1 times -1 is -1, and then this is 2 0, so 2, so we get a 1, and then this is 0, so this becomes a 1, right? And then rest of them, so these two don't matter because these two are 0, so these don't matter. We just need to take 2 times this and add it up, so that becomes 0, then 2 times this, so that becomes 0, then 2 times this becomes 0. Okay, in this case we just need to add up the first 2 columns, because 1 1 0 0 means you take this this row and then dot it, which means you just need to add these two columns. So this becomes 0, this becomes 1, this becomes 0, this becomes 0. Okay, 1 2 not 1, eliminate the third row, add these two guys and then 2 times this, right? So minus 1 2, so that becomes 0, then 2 minus 2, so that's 0, and then 2 times this is 4, minus 2 minus 1, so that's 1, and then this is negative 4 and then 2 plus 2, so that becomes 0, and then 1 1 1 1, add all of them up, right? So this becomes 0, this becomes 0, this becomes 0, and 2 minus 2 goes away and 2 minus 1 is 1. Okay, so this works, right? So that's why this procedure is basically the procedure of finding the inverse using Gaussian elimination, right? So what did we do? We started with this idea where Ax equal to B, but the columns B now are the columns of the identity matrix, and then that means we can write all of them here and then solve for all of them in one shot, and then we are looking for which x's basically solve this, right? And then we take the matrix, write the identity matrix to the right hand side, and then go through the steps for performing elementary, basically you do elementary transformations, so ultimately you can get to the row reduced echelon form, and then in which case on the right hand side you end up with the inverse, and this is just the verification for it. All right, okay, hope that helped. I'll see you in the next video.